everyone. For a sequence a sub n with our first term is 2 and our second term is 3, we're given this formula for n is greater than or equal to 1. We're going to find the rule for the nth term. So basically this is the quadratic method here, the formula for that. And so basically let's break this up a little bit so we can see the pattern. So I'm going to write this as a sub n plus 2 minus a sub n plus 1 minus 2a sub n plus 1. That gives me this minus 3 times a sub n plus 1. Then we still have this plus 2a sub n equals 0. Alright, now what I'm going to do is keep a sub n plus 2 minus a sub n plus 1 on the left hand side and move these two over. So this would be 2a sub n plus 1 minus 2a sub n. Well, this equals 2 times a sub n plus 1 minus a sub n. Alright, now if we let n equal 1, so if I let n equal 1, I'm going to get a sub 3 minus a sub 2 equals 2 times a sub 2 minus a sub 1. And then we're going to keep going on. So n equals 2. That would be a sub 4 minus a sub 3 equals 2 times a sub 3 minus a sub 2. And let's do one more. So n equals 3. That'd be a sub 5 minus a sub 4 equals 2 times a sub 4 minus a sub 3. Alright, and what we're going to do is look at this side right here, and then we keep going on. Let's keep going on. So basically, if we have a sub 1, a sub 2, a sub 3, a sub 4, and then if you keep going on, you'd have a sub n. The next term would be a sub n plus 1. The next term would be a sub n plus 2. And then you would have dot, 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 dot. All right. So basically, this first term is 1, right? Oh, a sub 1 is 2. So basically, if you look at this and go this way, this would be 1 times 2. This would be 1 times 2 squared, because we're looking at these 2's here. And then this one right here would be 1 times 2 to the power of n minus 1. And this one right here would be 1 times 2 to the power of n. So what I want to do is do a different sequence with b sub n. And I'm going to look at this part right here. This in here. And I'm going to look at these right here. And make my sequence b sub n as, excuse me, a sub 2 minus a sub 1, a sub 3 minus a sub 2, a sub 4 minus a sub 3, dot, 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 dot. All right. So this would be b sub 1, b sub 2, b sub 3. And these match up. So these 3's match up here, and the 2's match up, and the 1's match up. So since we this is a geometric sequence, because we basically had 1 times 2, 1 times 2 squared, then 1 times 2 to the power of n minus 1, and then 1 times 2 to the power of n. My first term is 1, because a sub 2 minus a sub 1, so that's 3 minus 2 is 1, and my common ratio is 2. So now we're going to go back to our quadratic method and use this formula, a sub 1 plus the sum from k equals 1 to n minus 1, and write our formula out as 1 times, I'm using this, 2 to the power of k minus 1. All right. Now, let's go ahead and, let's see. This is going to end up being 2, a sub 1 is 2, plus, and then using our formula, we're going to have 1 times, and then 2 to the power of n minus 1 minus 1, all divided by 2 minus 1. All right, so this is just 1, so we're going to get 2 plus 2 to the power of n minus 1 minus 1. So this is going to end up being, when you combine these two, your rule for the nth term is 2 to the power of n minus 1 plus 1. That's it. Thank you. Have a nice day. Bye-bye.